All right, welcome everyone. Another edition of TridiumTalk. We'll be doing another 4.11 feature sneak peek. Today's topic is BACnet Secure Connect. I'm Chris Riccobono, Senior Product Owner here at Tridium. With me today is Senior Developer Eric Anderson. He is the lead developer for BACnet Secure Connect and will be providing us with a great demonstration later. Also with us today is Melanie Coggin. She is a Tridium security champion and here to help us out if we find ourselves too far in the weeds with regards to certificates. And last but certainly not least, lead architect Blake Puak, here to help with moderation. So let's get started. As always, we kick it off with what's new with Niagara. Now, right now, currently available is our 410U1 image. This 410U or 410 at large is the long-term supported release. It's the release that you will see update builds made for, where we can provide security enhancements or patches to critical defects. And a special offering in 410U1, we finally finished our BTL listing and are happy to report you will see the supervisor, the JACE 8000 and the Edge 10 all up on the BTL website. And coming up, obviously, is 4.11. We are actively in beta testing and have a handful of sites running right now. We appreciate everyone's inquiries to wanting to join, and we'll be reaching out, letting you know that we'll likely populate a list as candidates for 4.12 for the next release. As we have, I think we've got quite the influx of inquiries. So bear with me while I get that replies out to everyone. And to highlight 4.11 releases, we have our famous features layout. Highlighted obviously is BACnet Secure Connect. That'll be our topic today. And let's dive right in. What is BACnet Secure Connect? You'll see it abbreviated as SC or BACnet SC. I thought the best way to start answering this question was to maybe ask a second question. There's always newcomers to the industry. Maybe there's building owners who aren't in the know. Maybe there's just veterans in the industry that haven't dealt with the protocol. So I thought, why don't I first just lightly cover BACnet and then how it evolved and got us to the point of BACnet Secure Connect. So what is BACnet? So it actually does stand for something, Building Automation Control Network. And it's a communications protocol developed by ASHRAE. So you may ask yourself, well, why did ASHRAE do this? And like all good engineers, you generally don't make something unless you got a problem to solve. And back in the late 80s, the industry problem at the time for building owners was certain controls manufacturers generally had their own proprietary communications protocol. So if you were a building owner, or worse, if you were an owner of several buildings, you may have had different vendors in to install different product lines from different manufacturers. And maybe you wanted them to at least have the ability to all communicate together. So their effort was to come up with a standardized communication between building automation devices from different manufacturers. And it's evolved over the decades and has become quite a popular standard for building controls. And one helpful part is that there's a governing body that's defining the specification or the rules for the protocol, and they're around to help evolve that protocol as technology evolves and meet the needs of all the applications that are out there. So those that are familiar with BACnet likely already know this. Possible link layers and current link layers supported in Niagara would be BACnet MSTP, which is a 485 serial connection. BACnet over Ethernet, not quite as popular, but still out there. And then BACnet IP, becoming more and more popular as we move forward with the industry's technologies advancements. Now, what's the problem with BACnet IP? Well, for some don't see it as a problem, some do. The communication is unencrypted. And often, from I think the building's perspective, that's less of a problem of ours, but more of a problem of, say, an IT department. They will not like to see unencrypted traffic on their network. And so often the way around that is a separate network, private VLAN, and we often have times where people don't want, or departments don't want to do that. And so ASHRAE got together to decide, well, security is such a critical point in the technology, and it's time to evolve and find an encrypted way, or a way to encrypt BACnet traffic. And that's how we got to today. What is BACnet Secure Connect? A new secure BACnet data link that uses standards widely accepted by the IT community. So what ASHRAE decided was, instead of just kind of coming up with their thing and then, enforcing it on the community, the industry, they again tried to tackle a problem. And if the problem was coming from a lot of the IT departments and their requirements, they did their best to align it with standards that are openly or commonly accepted, and wouldn't, at times can confuse an IT department when you try to explain it to them. So with BACnet Secure Connect, you have encrypted communication. It's via HTTPS over TLS 1.3. And ASHRAE was clever, understanding it takes a long time in this industry for things to adopt. So they had to come up with a way that you wouldn't suddenly make non-secure BACnet devices obsolete. One, it takes time. Two, it's cost. Building owners not going to be very happy if suddenly you said, hey, all these new controllers that we just put in, we got to replace them because your IT department doesn't want it. Now, what are some of the benefits or items that are addressed, part of that problem that ASHRAE was solving? Well, an IT professional would appreciate certainly the first one. You can leverage a domain name system to avoid static IP addressing for every device. I know I've been on a job site where I tried to explain to the IT, the network sysadmin, and said, hey, I've got these 200 devices. They're going to be on your LAN. They all have to have their own IP address. And they're all static. He just kind of laughed and said, go make your own network, or here's a VLAN, stay off my network. Now you have an opportunity to work alongside the IT department as they manage what's happening on their network. A second advancement in the technology is eliminating network broadcasting dependencies. So if you're familiar with BACnet, there's a lot of broadcast messages going around. Who is, who has, who is router. These are now gone, and where that really comes into play is if you have a large site and you've got multiple vendors and everyone's configured all of your BACnet configuration differently, or all the BACnet networks differently. A lot of times you end up with these router loops, and you can sometimes trigger a broadcast storm by, someone clicks global discovery, and next thing you know, you just took down the whole BACnet network. Another added benefit is no longer will need a BBMD, which often is a thorn in integrators' sides as they do their best to grasp the concept, understand it, and install it correctly. And then again, for the IT professional, there's no UDP or non-standard ports required. Those familiar with BACnet IP, it's a UDP protocol, and it was port 47808. I think I did that right. Being a typical port number is often blocked by firewalls, you would have to have the ask to someone, hey, you got to open up this port, which sometimes people are accepting to, sometimes they're not. More important is you may get the firewall open and then an update or a new hire comes in and closes them up, and now you got a phone call saying, hey, my BACnet devices are down, and you've got to troubleshoot what happened. And you come to find out, well, they just closed the firewall again. So let's take a little look at the architecture. This is sort of the layout from ASHRAE. And tied in a little bit of Niagara and Tridium products in here to kind of explain how this is supposed to unfold. So starting in the middle, it's a hub and spoke design. Orange circle being a hub, the Secure Connect links being the spokes, and down in blue are all the nodes. So what is a hub? Well, the hub's going to be the thing that's directing the traffic between the number of connected nodes, and is required for every BACnet Secure Connect network. This is tricky to use this word here because it has different meaning in BACnet, but it's essentially a router. So you could have a BACnet node that may have non-secure devices underneath it, but what a node can now do is provide a way for the information to be encrypted prior to ending up on the LAN. And so the design, or the intent of the design, is to be able to work with the non-encrypted devices and not just be this overbearing standard that maybe the specification engineer might throw out and say, hey, all BACnet devices must be Secure Connect devices. Now, what are some examples of the nodes? Well, you could have a device controller. We certainly already in the industry have some manufacturers creating native BACnet secure devices. Could be just a single thermostat. It's just another example, really, of a device controller. Facility workstation. You may have a PC running some kind of application that can perform operator workstation functionality or advanced workstation functionality per the BACnet specification. And that application could be have its own support for Secure Connect. And finally, a router to an existing BACnet system. So in the picture, the Jace, for example, has the MSTP trunk. MSTP, again, the 485 serial bus, no encryption there. But now the Jace is on a LAN, and it can send the messages to the other nodes via the hub. Now down below, a node can also communicate directly to another node. This isn't really the intent of that. It's not really to be sort of a permanent connection, but maybe temporary connections or one-off. Say you have your application that will download maybe the device program to the controller, and you just can get on the network, and instead of downloading and passing all the traffic through the hub, you can actually talk directly to the node and pass the file that way. Now, some of you have probably already caught on. A hub and spoke design generally has a flaw. You now have a single point of failure. So ASHRAE thought of this. They said, well, all nodes have to be capable of connecting to a failover hub in the event the primary hub is unavailable. So in this light drawing here, P being the primary hub, let's say machine goes down or access, the route to the machine goes down, the nodes will know where the failover hub is and know automatically to start connecting to the failover hub. Now, before we get to the demonstration, I thought we'd just kind of lay out how you're going to see this in the Niagara Framework and the offerings from us, as well as all of our OEMs. It'll be licensed. It'll be a feature, specifically the feature name is BACnet SC that you will see on the licenses. Supervisors, both Windows and Linux, JS8000s, and the NP-SDK portability offerings will all be licensed to be either a hub or a node. Now, the portability offerings, obviously that is not entirely ours to speak for. So obviously whoever makes the offering will be the one to decide what's appropriate, but we're making it available to them since the Secure Connect code is at the application layer. They don't have to worry about native driver development for their offering. They can just have it as soon as you put 4.11 on their device and as soon as it's licensed. Now, our Edge 10, however, will be licensed to be a node only. We don't want folks attempting to use the Edge 10 as a hub. It will likely struggle with a larger Secure Connect system architecture layout. So we make our way to the demonstration now. Question: how do you use BACnet Secure Connect in Niagara? How is it going to look? How will someone be installing it? And to help me with that today is Eric Anderson, and he will provide us with a nice demonstration. Without further ado, take it away, Eric.
Thank you, Chris. Thank you, everyone, for joining today. But Eric Anderson, software developer, worked hard on the implementation of Secure Connect, and want to shout out to all the other developers involved with that. It was a big team and a big effort. I'm really excited to get this feature out there and have customers start using it. Today, I'm going to go through configuring a few stations for Secure Connect. One's going node 1. I'm calling station node 1 is going to be hosting a hub function. Node 2 is going to connect to that hub function and also be capable of accepting direct connections from other nodes. And then node 3 is going to be a client only, initiating a connection to the hub function and also capable of initiating direct connections to other nodes. And at the very end, I'll show how we make direct connections. The first step, however, though, is to get all our certificates created and signed and ready to use within the Secure Connect ports. The first thing I'm going to do is create a site CA. The site CA can be a root or an intermediate CA. Within Secure Connect, the site CA certificate is referred to as an issuer certificate. We're trying to avoid confusion with public CAs, so we call it an issuer certificate to kind of reinforce that this site CA is specific to the site we're working on. All of the operational certificates used by Secure Connect nodes should not be signed should not be directly signed by a public CA such as VeriSign. This allows the site to control which devices are trusted by the Secure Connect network instead of trusting any device that happened to be signed by a public CA. So I'm going to create that site CA now. And under certificate usage, select CA, provide a password for it. I'll need the public certificate for the site CA later and when I'm doing the configuration, so I'm going to export it now. Next, I'm going to create a server certificate for node 1. Node 1 is hosting a hub, so it will need to both initiate a connection, a local connection to itself, and also accept connections from other nodes. So under here, under certificate usage, server is selected. When you create a certificate in Niagara like this, and you set the certificate usage to server, we set the extended key usage on that certificate to both client auth and server auth. So I'll be using this certificate to both initiate a local connection to the hub function, and I'll also be putting it in the web service to be used as a server certificate for accepting connections from other nodes. You could, if you wanted, have a separate server certificate that was just for server and just for accepting connections. While I have this, I'm going to generate the certificate signing request, and I'll process that in a minute. I've already created a certificate for node 2. Like I mentioned before, node 2 is not hosting a hub function, but it will be capable of accepting direct connections from other nodes. So this is also a server certificate, so that I'll use it later to configure the web service on node 2 to be capable of accepting direct connections. Now I'll create a certificate for node 3. As I mentioned before, node 3 will be initiating only. It will initiate a connection to the hub function. It will also, at the end, I'll initiate a direct connection, but it will not be accepting direct connections. It will not have a hub function, and so does not need to accept hub connections. So this will be a client-only certificate. This certificate could not be used in the web service for accepting connections. And I will also generate a CSR. Now I need to process all those certificate signing requests. For that, I'm going to use the newish certificate signer multiple selection tool. This allows me to sign these all at once. So I've selected my CSRs. My site CA is already selected. Provide the password and click generate. Now go back to certificate management and import the now signed. These PEM files were just generated. These are the signed certificates. Once they're imported, you can see the yellow icon turns green. All right, now that the certificates are in place, we're ready to start configuring the stations. Are there provisioning jobs for all of these steps? Yes, there are. At least for the Niagara stations or your Niagara network, you could create provisioning jobs to create a certificate, have it signed, and then import it back into the Niagara station. For pure or for non-Niagara BACnet devices, you'll need to use proprietary means at this point to create the private key on that device, generate a certificate signing request, and then sign and use a proprietary means to have that certificate imported back into the non-Niagara BACnet device. There are network port ways of doing that that should become standardized soon, and at some point we hope to add some network management features to Niagara to make that a lot easier. All right, node 1. So I've already added a BACnet network to this station, and I want to highlight one new property in the local BACnet device. This is device UUID. This property was added to support Secure Connect. The value of the UUID is auto-generated when you add the BACnet network to the station. It's persisted with the station. It won't change and shouldn't have to be changed throughout the lifetime of the network. I will now navigate down to the network layer. Over here in the BACnet palette, under network ports, we've added two new ports, SC port and SC hub port. The node 1 is going to be hosting a hub function, so I'm going to drag the SC hub port in. The only difference between the SC port and the SC hub port is that the link layer contains this hub function. I'll set the network number, configure the operational certificate. I'm going to select the one I created for node 1. Again, that's both a server and a client, so because it's a client certificate, I can select it here. Need to load the site CA, the public certificate for the site CA is an issuer certificate. I exported that earlier, and now I am loading it into the Secure Connect port. I'm going to enable the node switch to both accept direct connections and initiate them. The hub connector, the primary connection in the hub connector is pre-configured in the palette to make the local connection to the hub function in this port, and the URI path to that hub is pre-populated to match the servlet name of the hub function. Going to enable the hub function and click save. You'll notice when I save all these settings, the hub function has gone into fault. The fault cause is there's no BACnet SC user associated with this Secure Connect port. In order for the node switch to accept direct connections and for the hub function to accept hub connections, we need to associate a user with this Secure Connect port. Then, if the client certificate of the incoming request is directly signed by one of the issuer certificates configured here, and the URI that incoming request is using points to either the node switch or the hub function, then that incoming request will be accepted. So the user that we need to associate with this port kind of ties the web request, the incoming web request, with this particular port. There's a convenience action to add this user, and I've invoked that. You can see the fault cause goes away. This has gone into the user service, created this user, set the BACnet SC authentication scheme, or set the user's authentication scheme to a new BACnet SC authentication scheme that gives it a BACnet SC authenticator, and that authenticator is configured to point to this Secure Connect port. So now the incoming web requests will be accepted. The user that has been created should not have any permissions to anything in the station. That user's sole purpose is to associate an incoming web request with a particular Secure Connect port. So it should not have any read or admin or invoke permissions on anything in the station. The node switch and the hub function both have WebSocket servlets. The path to those servlets is set using the servlet name property on these WebSocket acceptors. In addition, there's also a web service ORD property. If it's set to null, then these servlets will be registered on the default web service for the station. So then the Secure Connect port will be listening on the same HTTPS port as all your browser connections. That may work for you. If it doesn't, you can add additional web services to your station, and then you would set the web service ORD for the node switch and or hub function to point to that additional web service. So if you don't want your Secure Connect traffic to come in on the default HTTPS port or the same HTTPS port as your browser connections, you can point the Secure Connect port to a different web service and then change the HTTPS port or set the HTTPS port of that web service to something else. For today's demonstration, I'm just going to use the default web service. So now I need to go to that web service and configure the HTTPS certificate. So here, main HTTPS cert, going to set that to the node 1 certificate that I created before. That again is both a server and a client certificate. So I'm going to select it. If you are sharing the web service with browser traffic, likely the site CA that we're signing all of our operational certificates is not going to be in the trust store for your browser. So your browser is going to complain because this main HTTPS cert is not signed by something that it trusts. There is an option to add additional HTTPS certs that can be presented to browsers based on the SNI header in the connection request. So you can configure your certificates in a certain way, give them a subject alternate name, and that is used to then present a browser-friendly server certificate for browser connections. So that option is available. There's documentation on how to set that up and what needs to be configured if that's acceptable. The BACnet standard did not mandate the inclusion of the SNI header, so we don't recommend setting the certificate signed by the site CA as an additional certificate. We recommend setting the main HTTPS cert to be the site CA or the one signed by the site CA, and then use additional certificates for the browser certificates. All right, so web service is now configured. I'm gonna go back to the Secure Connect port and enable it. Scroll down here. The hub connector has successfully made a local connection to the hub function. And if I go to the hub function, you'll see that there is a new connection that to itself. So to the local node that is hosting this hub function. All right, I'll move on now to node 2. Again, navigate down to the network layer. And this time, instead of dragging an SC hub port, I'm going to drag an SC port. So node 2 is not hosting a hub function. There will be one hub function on at least one hub function on your Secure Connect network, maybe an optional failover hub function as well. But this node 2 will be acting just as a node. configure it. At least selecting node 2's certificate as the operational certificate. Selecting the site CA as issuer certificate 1. I'm going to enable both accepting direct connections and initiating them. The hub connector, the primary connection of the hub connector. All these stations are running locally on my PC, so it also needs to point to localhost. And this is matching the servlet name of the hub function on node 1. Click save. Because we're accepting direct connections, we also need to associate a user with the Secure Connect port. And I need to go to the web service for node 2 and set its main HTTPS cert to the node 2 server certificate. And now I will enable the SC port. And the hub connector has made a successful connection to node 1's hub function. And here is the connection, the accepted connection on node 1. So this is the accepted connection to node 2. Finally, quickly configure node 3. Oops. There we go. Another SC port. Select node 3. This is a client only certificate. Select the site CA for issue certificate 1. I'm going to enable the node switch to initiate direct connections, but I will not enable it to accept direct connections. And then also configure the primary connection to also point at localhost. So I can enable this SC port, no configuration of the web service required, and it initiates, makes a successful primary connection to node 1's hub function. And we can see that third connection here on the hub function. So all the nodes now are connected to the hub function. And I'm going to go over here to node 2. And come on. Run device discovery. So right now it is sending a broadcast message. Node 2 has sent a broadcast message to the hub function. The hub function has distributed that broadcast message to the other nodes, node 1 and node 3. Node 1 and node 3 responded with unicast messages sent to node 2 that were also sent to the hub function, and the hub function has directed those messages to node 2. So we now have discovered node 1, node 3, and can add those to node 2's BACnet network. Last thing I want to show, almost done. Last thing I want to show though is making a direct connection. So I'm going to initiate a direct connection from node 3 to node 2. Under the node switch for node 3, I can invoke an add connection action. I call it node 2. Node 2's HTTPS port is 444. It's listening on 444, and the path to its node switch is still at the default value of node switch. So I've created an initiating direct connection, and I can call a connect action on it. So it now has made a successful direct connection to node 2, and we can see that here under the node switch. So this is the accepted connection from node 3. And any traffic that, any unicast messages that were either going from node 2 to node 3 would be now routed, would go through this direct connection rather than being sent through the hub and then directed to its destination. So that is it for me. I'll turn it back over to you, Chris. Thank you, everyone.
Yeah, thank you so much, Eric. That was excellent. All right, I'll wrap up the last few slides fairly quickly, and we can get to the Q&A. We like to always give a nice shout out to the Tridium University website. Lots of e-learning, both free and for pay content there. We can pick up lots of good tips. Where can you find more Tridium talks, including this event? Once we finish recording and draft up the Q&A, you can find it right on the website, tridium.com, services and support, and then click on events. And if you want more Niagara Pro tips, you can tune in to our famous YouTube stars, James Johnson, Kevin Mamajek. They have great content up on the website, and feel free to reach out to them as well on the community forum if there's something specific you'd love for them to talk about more or create a video. And that'll take us to the Q&A. We've been answering a couple of the questions in the feed with direct answers, but we have a couple of questions I think we want to answer live.
Yeah, we've had a number of great questions come in throughout this presentation. Hopefully we've answered some of them during the presentation, but there are definitely a couple that I would love for you and Eric to answer for the audience here, Chris. First of all, do we plan on providing or do we have a published list of the BACnet SC devices that we've tested against?
Ooh, that's a great question. I don't have that, but I'll work on putting something together and can provide that. I'll see if I can post that along with the video.
Very cool. We have a number of questions about the network topology and how devices may communicate with each other and other network requirements. First of all, if we have mixed devices, some older, perhaps BACnet IP devices, as well as BACnet SC devices, are they both being handled by the same driver within Niagara?
Yes, you can continue to have the IP link layers that have always existed in our Niagara BACnet driver, and the same routing functionality will work. So you can route messages from received on an IP link layer out to a device reachable through a Secure Connect link layer, through a Secure Connect network.
Okay, and Chris, on your network drawing, it may have appeared that you had a Niagara 4 supervisor acting as a hub. Would that mean a typical setup would need two supervisors, one acting as a primary hub and one as a failover hub?
Yeah, for clarification, that diagram is definitely just an example, not the requirement. So I threw the supervisor as just sort of an example hub, and you're absolutely free to use a JC1000 as the hub. And now in terms of having a failover hub, you could have, if you wanted to, you could have two PCs, two supervisors, one supervisor, one Jace, or just two Jaces, as one acting as the primary and one acting as the failover. This sort of feeds into another question. I know that might throw the list off a little bit, Blake, sorry, but I saw a question further down about network traffic considerations. So as you've kind of seen now, this is all happening via HTTPS and is leaning on the power of the web server, the Jetty web server in Niagara. So if you have a very large, robust site, you want to be able to back it up with hardware. So if you have an enormous site and everything's BACnet Secure Connect and you're going to be routing it through a hub, it's a likely best practice to be putting that on a PC rather than an embedded device. So it's about providing the right product for the right application. Doesn't mean that you can't do it. Just, it's one of those funny answers of it depends.
Great. So we have a couple of questions that came in about certificates. Definitely a complex subject to handle. So the first one I have is, how will Tridium address SC certificates in third-party controls, such as ones that OEM IP controllers that the JS is supervising? Is this going to be specific for vendor?
So non-Niagara BACnet devices, you will need to use proprietary means to create private keys on those devices, generate certificate signing requests, and then re-import the signed certificate. So once you have the CSR and you can pull that out of the non-Niagara device, you can sign it with Niagara tools, and then you'll need to use a proprietary means to push that certificate back into that non-Niagara BACnet device. There is a network port standard being developed. It's in public review now, and so at some point when devices get to a certain protocol revision, there are network port ways of exchanging certificate signing requests and setting the operational certificate. But until those interoperable ways are available, we'll have to rely on proprietary means of exchanging certificates.
And I don't want to put you on a spot for a demo you're not prepared for, Eric, but a demo of revoked certificate management, would you be up for that, or should we put that in our documentation for users to follow along?
Yeah, that's we do support CRLs, so certificate revocation lists. We have descriptors that can go out and for a particular site CA, retrieve a CRL and then enforce that CRL. That is tricky to configure, and I think it would be better for a separate demo. There is as part of BACnet's new network port support for Secure Connect, there are procedures in there for how you can update the site CA and then also update operational certificates in order to exclude devices if necessary. Those really rely heavily on the interoperable ways of generating certificate signing requests and setting operational certificates. So those procedures could also be a way of revoking or excluding devices that are no longer trusted. So yeah, so that's an option. We do have support for CRLs. I think demoing it would be tricky, so we'll do that in a separate demonstration.
Thanks, Eric. And a number of our users are used to using tools like Wireshark to do network captures to help diagnose issues in the field in the past, especially with BACnet IP and such. Is that still going to work now that our traffic is encrypted?
There are means of importing private keys into Wireshark so that Wireshark is able to unencrypt the encrypted traffic so it can be sniffed. We also have we've tried to add as much logging as possible so you can see the messages once as they're being routed through the hub function or as they're being received on the hub connector. Logging those messages so you can see either all parts of the traffic. So yeah, Wireshark, there are ways of doing it in Wireshark. They can be a little tricky. We've also tried to supplement that with logging within Niagara to assist with debugging what's going on.
And Chris, a number of people have been asking about how we're going to license BACnet SC. Could you give us a little information on that?
Yeah, I touched on it a little bit, but one key thing I should have mentioned, yes, this will be included in the standard device license. So just like any devices and supervisors, portability kits that have the BACnet feature, this BACnet SC feature will be added to those devices as well.
And so to be a node, you don't need the BACnet SC feature. So if your device is only going to connect to a hub function, as far as I understand, that's included with the BACnet regular license feature. And so a node connecting to a hub function, no problem. If you want your node to host a hub function, or you want your node to accept or initiate direct connections, that's where the BACnet SC feature comes into play. But if you're just a node wanting to connect to a hub function, no additional licensing required.
Excellent. So the more of a technical question, probably for you, Eric, about the UUID that we have that identifies these. Is that persistent within the station or on the device itself, such as if I wanted to run 2 stations on a supervisory device, could they have their own unique UUIDs?
Yeah, they will. And that UUID is unique to a particular BACnet network. So the BACnet local device for that BACnet network has the UUID. It's persisted with the station. It's not persisted with the host. So 2 stations running on the same host will have their own device UUIDs.
Do we have any limits, or are we aware of any operational limits on the number of nodes that can be supported in a BACnet SC network?
Yeah, so the limits, what we've been shooting for, or what we're trying to target, so the number of 1,000 has been thrown around in kind of the BACnet IT working group as a rough target for how many nodes a hub function would support. So that is kind of our rough target for what we want, like a supervisor station to be able to support. JACEs, they don't have as many resources typically as a supervisor station. There's a rough number, 250 out there. That's off the record. It really depends on what else your JACE is up to, how many points it's supporting, what other networks it's supporting. But those were some rough targets that we were shooting for. So 1,000 roughly on a supervisor station's hub function, and then 250 connections accepted by hub function on a JACE, 8,000 NMSDP and PSDK devices, of course, will depend on what resources they have available. And all of this depends on what else that station is configured to do.
Okay, let's see. What about the speed compared to BACnet IP? Have we seen the encrypted traffic behaving significantly more slowly?
Great question. I don't have any of those performance metrics with me. We need to run those tests, and we can compare that performance, but I don't have those right now. I would expect it to be a bit slower. I mean, it is doing a lot more work to encrypt that traffic, but I don't have any comparisons handy.
Okay, Chris, I have a question about the overall market, and perhaps this could also stem a good discussion on the Niagara Central forums amongst our community, but do you see a time where customers will demand that BACnet IP will not be allowed to run on their job sites and only BACnet SC will be allowed?
Yeah, it's a really good question. Unfortunately, if I had the crystal ball, I could tell you definitively, but I think the best guess, or my opinion, would be while we have seen some already, kick off BACnet IP off of their site, off their network. It's mostly about applying the right technology for the right need. And I think if there's any, for the specifying engineers that may be on the call, it's just because it's secure doesn't necessarily mean it's, this is the right application needed for all, or for the wide scope. So it's important to really understand what the intent of this technology is, and what it allows, and allow the customers and building owners to decide what they need, as long as we educate them correctly with the technology needs and the demands of the industry.
Thank you. A couple more technical questions. Eric, is there a limited range for the WebSocket ports that can be defined?
Not that I'm aware of anything that. So it's going to use standard WebSocket secure URIs. So any, the allowable range of ports as far as the URI standard is concerned, we're using standard WebSockets. So connecting to, we should be able to connect to any WebSocket port, and then I think you have the full allowable range in the web service for what ports can be selected.
I have a question here about our plans to add multi-factor authentication in the future. I believe that is going to apply to our Niagara systems in general, rather than BACnet SC specific, unless Eric, you can think of a use case specific to BACnet SC.
No, I can't think of how BACnet SC would leverage multi-factor authentication, just because we need a user. As far as I'm aware, you would need a user to provide some additional information coming from a different source, and I'm not sure how machines would achieve that same thing. So as far as the BACnet standards go, I haven't heard any discussion about incorporating multi-factor authentication for Secure Connect.
Okay, and then on the Niagara side, we do offer the Google Authenticator option for multi-factor authentication. See if we have time to squeeze in these last two questions before we hit our limit today. Chris, have we already incorporated BACnet SC into our either Tridium certification or the advanced certificate classes, or do we have plans to offer any supplemental, perhaps online learning courses specifically tailored towards BACnet SC?
Yeah, great question. We'll work with the training department to find the right solution there. It's probably a bit much to bring into the TCP class, as there's so much to learn. Just getting your bearings there. It could be in the advanced, or possibly even just a nice e-learning module that can kind of more specifically focus on Secure Connect and certificates, for that matter.
Great. We do have a couple of more questions in our Q&A, but I realize that we have hit our time limit for today, so we'll make sure we get all those remaining questions answered and posted in the Q&A document that will be up online with the recording of this session over the course of the next couple of days, or perhaps early next week.
Yeah, this is great. Really appreciate everyone joining us today. Eric, Melanie, Blake, thank you very much. And yeah, like we mentioned, you'll find this recording once we're finished up on the website. Could likely be a great resource for training going forward. I know I always have that problem where I won't touch this for a while, and it'd be nice to have a video to see it in action. So thanks again for joining us, and I hope everyone has a great rest of the day.